Congruent polygons have corresponding angles and side lengths that are the same or congruent. Side lengths, congruent. In order for them to be congruent, each angle that corresponds with the other angle has to be congruent, and each side has to be congruent to the other side. So number one, list the congruent corresponding parts of the figure below. So it's telling us that the triangle TJD is congruent to the triangle RCF. So that means the side TJ is the same as RC. So if I go over here, TJ and RC are congruent. So I'm going to write TJ is congruent, and I want to go, if I say TJ, I want to say RC the exact same way. So the segment RC. And now the next segment is going to be JD and CF. JD, CF. So I write JD is congruent to CF. And the last side is TD, RF. So TD, 1, 2, 3, RF, 1, 2, 3. So TD, RF. The segments. Now I also have to say what the angles are congruent. So angle T is the first position. That matches up with angle R, the first letter in the other triangle. The second letter is angle J, so that's congruent to the second letter over here, angle C. The third letter is angle D, and that's congruent to the third letter angle F. So when you're listing the corresponding congruent parts, you have to put angles and sides. So this is a quadrilateral. I'm just going to draw it out. A, B, C, D, and go in the same order, E, F, G, H. So first I'm going to do the angles. So angle A is congruent to angle E because they're both the first letter. Then I do angle B is congruent to angle F because it's the first letter. Angle C is congruent to angle G because it's the third letter. And angle D is congruent to angle H because it's the fourth letter. Now I'm going to do the side lengths. So the side lengths, I would do AB, the segment, is congruent to EF, the segment. BC, the segment, is congruent to FG, the segment. And then DC is congruent to HG, just keep organized. And AD is congruent to HE. So make sure you're labeling the angles and the sides. Decide whether the triangles are congruent. So in order for them to be congruent, they have to have the same angles and congruent sides. So just looking at it, I know that this 4 and this 4 is the same. And I can mark this 3 and this 3. And I have these two angles. This angle is the same as this angle, and this angle is the same as this angle. So I need to have another, I already know that these two are vertical angles, so I have 3 angles. Now I need to have 3 sides. I do have, well actually this mark I think is supposed to be over here because this 4 doesn't have one. So I do have 3 angles and 3 sides are congruent. So they are congruent. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. So if 2 angles of one triangle are congruent to 2 angles of another triangle, that makes sense that the third angles are congruent because they have to add up to 180, so these two would have to be equal. So let's say this was 80, this was 80. This was 60, this was 60. This one would have to be 80, this would have to be 40. So that's why that works. Okay, so in triangle XYZ, we should draw out a triangle. It's always easier. X, Y, Z. And draw a triangle KLM in the same orientation. So X has to match up with K, Y has to match up with L, and Z has to match up with M. So if I know that angle Y is 67, I know that angle L has to be 67. And if angle M is 48, then I know that Z has to be 48. So how can we figure out what X is? X has to be 65 degrees. And so does K by the theorem above. Okay, I went ahead and wrote my conclusion and my justifications, and now I'm going to, in my givens, so I took all of these up here and I wrote them down for the givens. Now I'm going to mark my diagram. So by marking I mean put the hash marks, the angle marks, from each given. So if CG is congruent to DG, I'm going to mark those both 1. CN is congruent to DN, I'm going to mark those both 2. And angle C is congruent to angle D, I'm going to mark these. And we know that angle CNG and angle, or triangle DNG are right triangles. So therefore, angle CNG is a right angle, which is congruent to angle GNG by that right angles are congruent. So far I have 2 angles, and we know that the third angle has to be the same too by the previous theorem. So we can say that angle CGN is congruent to angle DGN, which is up here. These two are equal. By the theorem before that said the third angles are congruent if the first 2 angles are congruent. So I have 3 angles and I have 2 sides. I don't have the last side. But if you look, these 2 share the same side. So GN is the same for both triangles. So I'm going to write GN is congruent to GN. And what property does that look like when you have the exact same thing on the left and right hand side? That's called the reflexive property. So now I have 3 sides and 3 angles, so I can prove that triangle CNG is congruent to triangle DNG by definition of congruence. Okay, I went ahead and wrote down all my givens, and there's 5 of them, so I'm going to go ahead and mark them. So angle A is congruent to angle D. Mark that. Angle E is congruent to angle C. Mark that. Angle or segment AE is congruent to DC. Mark that. EB is congruent to CB. Mark that. And then BA is congruent to BD. So 1, 1. So I have 3 sides that are congruent, and I only have 2 angles. But I do know I can either say by the third angles are congruent, or I can say these 2 angles are congruent. I'm going to write down that ABE, the angle, is congruent to, so this angle and this angle are vertical angles. So congruent to angle CBD by the vertical angle theorem. Now I have that I have 3 sides, 3 angles, so I copy down what I need to prove. Triangle AEB is congruent to triangle DCB by definition of congruent. Figures or polygons would work too. Later on, we're going to have a lot different triangle proofs that we won't have to prove this many things in order for them to say they are congruent.